Dear participants, we will begin the session shortly within 5 minutes. So kindly wait. A very good morning to one and all present here. Respected speakers for the day, Dr. Sarika Hegde, Dr. Rashmi P. Shetty, Dr. Ashwini B., and all the participants. I, Nikita Saurabh, Assistant Professor, Department of Information Science and Engineering, welcome you all to this webinar series on Artificial Intelligence, Current Trends, organized by Center of Excellence in Artificial Intelligence and Machine Learning. The Center of Excellence in AI and Machine Learning, which was inaugurated on 31st October 2020, was formed with an aim of providing a platform for students and faculty with similar interests to collaborate, share their knowledge, and work together towards making significant contributions to the field of artificial intelligence and machine learning. The main objectives of the center are enhance research and innovation in AI, promote interdisciplinary projects, and knowledge transfer for faculty and students. This webinar series is the first step in this direction. Now, without taking much of your time, with great pleasure, I would like to introduce to you our first speaker for the day, Dr. Sarika Hegde, who will enlighten us on the topic AI research trends in computer science. Dr. Sarika Hegde is working as an associate professor in the Department of Computer Science and Engineering at NMAMIT Nitte. She has 17 years of teaching experience. She has obtained her BE and MTech degree from NMAMIT Nitte and received PhD degree from Mangalore University in the area of applications of statistical techniques in automatic speech recognition. Currently, she is active in the research areas of natural language processing and speech disorder. She is also a co-PI for the VGST funded lab, Center of Innovation in Automatic Speech Recognition and Natural Language Processing in Kannada language. We are eager to listen to you, madam. Over to you.
Thank you, organizers, for giving me an opportunity to present in this session. Since this webinar is a part of activity by Center of Excellence in AI and ML from NMMIT Nitte, there are many more such events going to come in future. And this session is the very first one among that, which I will be presenting today. So I will be focusing on the basics of AI and ML. Maybe many of you must be having a very good idea about that, but still, to maintain the flow for the entire series, it is important to set the fundamentals right. So these fundamentals will help us to understand or appreciate the coming sessions on current trends of AI and ML. So let me start with the presentation. I hope the presentation is visible.
Yes, ma'am, it's visible.
Okay, thank you. So the topic which I will be covering in today's session is the basics of AI and ML. Because without understanding the background technique, whatever we talk on the upper side, like application side, may not be very much appreciable. Like people may not understand how exactly the things happen in the background. So the topics which I will be covering is like what is artificial intelligence, machine learning, why machine learning, the different techniques, and specifically what we are doing, that is our research work in this, which is related to machine learning. So artificial intelligence, as this picture shows, the two components that we need to see here is one is the chip and one is a face. That means actually, it is a chip which is working, but on an outer look, it looks like a human. It looks like some intelligence that is working. So artificial intelligence is all about that. You have a chip or the computer program that is working, but for a user, for an user who is interacting with the computer, it looks like a very smart person sitting outside, sitting across and operating with that user, responding to the user. That is the overall idea of artificial intelligence. So what is the objective of artificial intelligence? We want the computers to be intelligent like human. So there are two terms here. One is a computer and one is a human. And what we want is we want the computers to be intelligent like a human. So when we say human, what is that thing that comes into our mind? So it is a way human do the task. We are focused on how humans do the task. So human will perceive things by patterns. That is one characteristics of specialization that we are focusing at in this subject, artificial intelligence. When it comes to computers works based on logic. So this is a key difference between the way human and computer works. Human works by patterns and computer works based on logic. For example, if you see these two numbers, so both of these numbers are 10-digit numbers. But if you just glance over it for a second and close your eyes and try to recall what is that number, I'm sure that most of you will be easily able to remember this first number. And even if it is both of the numbers are of same digits, it is difficult to remember. It takes time, it takes certain effort an individual to remember this number. So why it is happening? Because we are good at remembering the pattern. As soon as we see the things, we capture the pattern. So there is a pattern in this number. Okay, and we capture the pattern. It allows us to easily remember the number. But here there is nothing as such. There will be some pattern, but it takes some time. Now, for a computer, if you store these numbers in this computer memory, it is going to take the same amount of space. The time needed to access the data will be same. The time needed to, if you are doing any operation, will be same, because computers, it is number of bits or bytes that is used to occupy the space. Okay? Now, if you take this example, it is a multiplication example. And if I ask you, okay, can you write the steps, how this multiplication is done? So it will take some time, but you can write the steps because there is some logic here. There is some algorithm here. So what is the first step? 4 is multiplied with 2, then 2 is multiplied with 2. Like that, you can write the things in steps. And if you follow that step, any number given, if you follow the steps, we can get the accurate answer. So there is a certain, for a certain input, if you follow the certain steps, you are going to get a definite answer. So these kind of operations are logic based, where you can write the steps, you can express the logic as an algorithm, and you can feed that into the computer as a program, and program computer will give you the answer anytime accurately for any number, irrespective of what is the number, it will give you the answer accurately. It doesn't matter if you change the input, the output will remain same. So such kind of what we were doing with computer is we were writing programs for such kind of problems before the concept of artificial intelligence came. This is traditional way of using the computer to write the program, and the kind of task it can do very easy. But if you see this example, there are two pictures you can see here. As soon as you see this picture, you can easily make out the first one is a dog and second one is a cat. But if I ask you, how did you do that? Or can you write the steps, like what you did first, what you did second, what you did third? How do you came to a conclusion that first one is a dog and second one is a cat? So then it becomes difficult actually, because it is very easy for us to capture. We have captured some patterns unknowingly, but if I ask you to write the steps, it's not so easy to write it. And like such kind of dog, you may not have seen in your entire life exactly the same dog or exactly the same cat. You may not have seen, but still you're able to identify that it's a dog. Or any dog, maybe like how many variety of dogs are there in this world? You are not, maybe you're not just seeing 2% of that variety, but still you're able to identify all kinds of dogs. Looking at a dog, you can see it's a dog. But if someone asks you how do you do that, it's not easy. At least for a given picture, like for this picture exactly, if you tell to write the steps, okay, we can write with exact same posture, same color, same texture, everything same. And if you do that, okay, to some extent you may you may able to write the steps. But if it is asked to generalize, like how we humans do, if we ask to generalize and write a step which can identify this, so that is not possible to write with the traditional programming what we have seen till now. Okay. So what we are trying to do here is understand what humans can do and what computers can do. So humans are good at reasoning, humans are good at learning. It just comes like that. We don't need to do any special effort. It just comes like that. Perception, linguistic intelligence, decision making, etc. But computers are good at numerical computation. Any numbers you give. If I ask you, okay, what is 10 into 5? Quickly you will tell me the answer, 50. If I asked you what is 117 into 56, it takes time for you to answer. It takes more time. Like, and it depends what is your mood, at what context you are. All those things matters in deciding how fast, how accurately you will give the answer when it comes to numerical computation. We are not good at numerical, okay? But when it comes to computers, they are good at numerical computation, because computation, once a sequence of steps are defined, they will do the computation. They will find out the answer. And there is no bias. You give any number. There is no liking, disliking for the number. There is no timing. You give 100 times same numbers, you give same task you do. So computers are like this and humans are like this. Now what we want to do in artificial intelligence is we want the computers to be intelligent. That means what? We want the computers to exhibit characteristics of a human, because we want the computers to be intelligent like humans. So we want the computers to exhibit those characteristics, that is reasoning, learning, linguist perception, linguistic, all those things. At least one of these tasks, at least for one of the tasks, any one of these characteristics, we want to incorporate that into a computer for it to say that it is intelligent. Okay. How do you do that? So artificial intelligence is a concept. It's a broad concept which says we want the computers to be intelligent like human in performing any task. Okay. The question is, how do you do that? What are the different approaches? There are different approaches like rule-based approach, fuzzy-based logic, so many approaches are there. But none of these became so popular. And with all those approaches, we could not see much of the artificial intelligence applications in the real world. But now we can see it everywhere. Everyone is talking about, we are using the applications. So how it became so popular all of a sudden? Again, because before it was at once, like when the topic was introduced, it was popular. But after that time, it did not become so practical. So it just went off. But again now, maybe for the past 10 years, again it has come back. So why that has happened? Because of an approach that is uh, called as machine learning. So machine learning is an approach which makes artificial intelligence concepts come into reality. It is one of the technique, and this technique has been proved to be very practical, very realistic. Means it has, using this we could do, and we have a very bright future also regarding this AI and ML. Now we will look at like what is machine learning. We'll try to understand the basic of that. So machine learning is one of the approach to implement artificial intelligence. What is the idea behind machine learning is, you give the machine, when I say machine, it is a computer program or the computer algorithm. When we say the machine, so what we do is we give the machine access to the data. So you give the data to the program and let it learn by themselves, looking at the data, like how we human look at the things, and we just try to match the things with our memory, and we try to learn the things, new things, and we keep updating ourselves. That's a continuous process until we die, means until the last breath, that thing we do. So we are continuously learning, so we are continuously looking around, sensing the things around, and we are updating ourselves. So same, we want to have the same concept with the machine learning computers also. So we are giving just data to the computers, and we are asking it to learn by itself. Okay. And so how do you do that? Let us see that. So for example, we when we say that, so we are giving computers access to data, and we are making them learn by themselves. Okay. So when that comes, there are three terms which comes into picture. One is a task, experience, and performance. What is the task that you want the computer to do? How do you provide the data? What kind of experience, or how do you evaluate that it is doing the task? So these are the three terms by which we define machine learning. For example, you want the computer to play chess. You want the computer to learn, and you want the computer to play chess. So what is the task? Task is playing chess. Now, how do we learn playing chess? You can't just by heart the rule and start learning the chess and win the game. It's not possible. So how do we learn the chess? We know the rules in advance. Okay, fine. Then we start playing the game. So we start playing the game. We may lose many times, and as we lose or as we win, we try to capture what went wrong or what went right. So we try to capture those things, feed in our mind, and then we update ourselves. And every time we play a new game, we are actually improving every time. Okay, so that is experience. As you become experienced in any task, your performance improves. If you're not learning, means if you're not just bothered, you're simply playing the chess, whatever happens you're not bothered, and you tend to give the same performance every time. That means you're not learning. So when we say machine learning, is it learning or not? How do you say that it is learning or not? So that is by measuring its performance. If when you as we provide the experience to the computer program, if the performance is improving and improving, then we say that it is learning. So when it is a playing chess game and you provide the examples, practice games for the computer algorithms, and as and when it plays the games, it learns, means it keeps the data about that, then we say that it is learning, and its percentage of winning is increasing every time, then we say that it is learning. So overall, this is a very basic definition of machine learning, how you define machine learning with three terms, that is task, experience, and performance. Machine learning is a field of study that gives a computer the ability to learn without being explicitly programmed. We are not saying each and everything, do like this, do like this, do like this. We are just saying how to learn. That's all. How do you learn by yourself? It's like you say your students do self study and they have to find out, like they have to do their study on their own. But we do guide them how to do self study. So it is like that. You tell the computer how to learn. So that is our job as a programmer. We need to write a program which says how to learn. Then, given the data, it has to learn by itself. So when do you say, so this is defined by the author, well-posed learning problem means a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. The same thing which I told here. So it is like this. You have a task to do and you have been given an experience for a machine, I'm saying. As the experience increases, if its performance is increasing, then we say that it is learning. Okay. So what kind of task can be done? Let us say predict the price, house. You give the data about a house, like how many rooms are there, what is a square feet, in which location it is, all kinds of data about the house. And you want to predict what could be the price of that house. So you want the computer to predict, or you want the computer to predict the stock price, or you want the computer to segment when there are group of customers, lot of customers data, you want the computer to identify these customers belong to same type of purchase behavior, or you want to optimize the user flow, or you want to categorize the images. So these are the kinds of tasks which we can see. It is very specific. You can't expect the computers to do all the tasks that human do, like all we are good at everything, but we can make computers to be proficient, means efficient in one kind of task. So you select what kind of task that algorithm can do. So what kind of task it can do, predicting the prices, or what kind of task it can do, segmenting the customers, and so on. Now if you want the computer to predict the prices by itself, what kind of experience are you providing the computer to learn? It has to learn, right? Without learning it cannot do it. So that experience is providing in terms of data. So you have some hundreds of house data or thousands of house data. You collect all those data and you feed that to the computer algorithm. Looking at the data, it will try to learn. Okay, if the input is like this, the output will be like this. If it is number of bedrooms and it's so many bedrooms and this is this location, then the output will be like this. So in looking at the data, it will try to understand that output should be like this. So now, as you provide more data, so data is an experience. How we capture the things with our five sensing organs, and we try to build our memory or our intelligence like that. This is we need to also we provide in the similar way we provide the data to the computer, and it will take the data, it will turn like try to learn the data from the data, and it will do the task. Okay. Now we need to also evaluate it. As a programmer, we need to evaluate it and we need to see is it really learning or not. So how is it giving the prices accurately or not? So such kind of some evaluation mechanism will be there for understanding whether it is performing. So here we are trying to understand what is machine learning. So like that, for example, if you want the computer to drive a car, means a robot to drive a car, inside that robot, a program should be there which does machine learning. So what is the task here is it has to learn to drive on a public four-lane highways. And what is the input that is coming through? A vision sensor is there. That means through vision sensor, you're capturing the images continuously. maybe every one like 0.1 second or 0.5 seconds, like that, in terms of that, or 1 second, every 1 second you're capturing the images, and just you capture the image and you have to take, means you have to respond for this kind of situation of the road. Should that computer turn the steering to left, right? What is the decision? So input which comes is through the sensor, vision sensor, as an image. To that image, the robot has to respond by giving the commands to the steering. So steering has to be turned appropriately. That is a task. Okay, now how do you give what kind of experience? So how are you going to see the performance? How much, like, we need to evaluate, okay, is it driving properly or not? So what is the average distance travel before it does any mistake, like it does a mistake, any kind of error, maybe it hits or maybe it turns in a wrong way, whatever. So before that, it travels 1 kilometer, 2 kilometers, 5 kilometers, 10 kilometers, how much it has traveled. If the distance traveled is increasing every time you make it better, then it is learning. So how do you provide the experience to this robot? Experience, so someone has to sit as a driver to provide the experience, and whatever data comes as a images and whatever response that driver gives, the human driver, that has to be captured continuously. So we need to capture all those sequence of images and the corresponding commands, action, reaction, response, and it has to be given to the algorithm. Now, algorithm will look at the image and the corresponding response, and it will try to learn for this kind of image, this should be the response. So that is machine learning. When you give the data, the input and the output, and it tries to learn the relationship between the input and output, and that it will, whenever a new data comes, it will be able to tell you what is the output. That is what is machine learning thing. So like that, you can have for different examples what is the task, performance, and experience. You can start thinking in that terms. Okay, now why machine learning has become so popular? Because it works based on data. So we are not actually teaching each and everything to the computer. It learns by itself looking at the data. That is one thing, lighter side of that. But the main reason, because of the emergence of the internet and the huge increasing in the amount of digital transformation being generated, stored, and made available for analysis. So you have data everywhere now. Facebook, you open so much, so many kinds of data, varieties of data. YouTube, you open so many kinds of data. WhatsApp, you open. Data is there available everywhere. Twitter is there. So now data is there. It is there. Even if you don't use machine learning, artificial intelligence, data is there with you. Lot of data. So now if something is using it and trying to make things better, usable, user friendly, like how Google does, so many kinds of application it is bringing. One best application that you are using with Google is when you compose. So you get a email and it gives you the suggestion what should be replied back. That level of data it has gathered and it has learned for what kind of message in the body, email body, what kind of reply usually people give. So it has learned that mapping between the composed message and the response that a user. Now it is able to give you the response. So data is available everywhere. It could be made use of that. If you are good at machine learning, you can make use of it and you can really bring a practical, efficient machine learning applications. Or techniques. We will talk about the techniques. Like how do you actually learn? Means, for example, image is there. For car driving, image is there, and there is a response, right? How should be the steering commands? Left, turning right, turning straight. How much degree? That is a response. So these data you have, now you have to write a program which maps, okay, for this kind of input, this should be the output. What is that actually? That is the technique behind machine learning. So this diagram is more of means technical. So you have a raw example data. For example, image here is a raw data, and you do some kind of processing there. Now, data could be of any type, but we need to do some processing. Your algorithm, now a computer algorithm or just an algorithm, cannot take the image as an input, just like that. So image has to be processed, should be brought into a form which could be easily stored, processed, managed by the algorithm. It is more comprehensive, means it is more of understandable. Image, if you give, image is what? It's just a set sequence of pixels. What you derive out of just a set of pixel values. But now you see, okay, brightness is so much, color is like this, edges are like this, curve is like this. So that becomes more meaningful. You have a raw data of image, now you make it more meaningful. Say, okay, color is like this, shape is like this, texture is like this. So you do some image processing there, and you bring the data in a more understandable format. So that will be now given to the machine learning. So machine learning starts from here. Okay, machine learning starts from here. So we assume that in machine learning, we assume this is available. This is called as X. X is the input, like your image is processed and it has brought into some format, some specific format, that we call as a X. And what is the output that you're expecting? Staring, rotating left, right, straight, what is the degree? That is Y. So you have a X and you have a Y, okay, which we call as a data. And data should be in this format for the machine learning to operate. So from here onwards, mathematics comes into picture, and the algorithm comes into picture, and how it processes, how it learns. Actually, there is a X and there is a Y. So what is the relationship between this X and Y? Like, if X changes, how Y changes? What kind of changes in X brings the changes in Y? It is simply simple mathematics. It is actually not simple mathematics, but it is really purely mathematics. So it has to learn the relationship between this X and Y. Until you bring this raw data into this format, that is X, there it is domain specific. For example, if it is image, you apply image processing and you bring it to this format. If it is audio, you apply signal processing and bring into this format. If it is text, you apply natural language processing and they bring into this format. So what kind of domain, what kind of data you have, you apply that kind of processing. And finally for machine learning, it is independent of what kind of data it is. For machine learning, it is just data is available in this format X and Y, then machine learning starts. So from here it is up to here it is domain specific, which will change from one application to another application. From here onwards, all the application will come into same thing. It is machine learning algorithm you need to apply and make it learn. So ML algorithm will take this input X and Y, and it actually learns what is the relationship between X and Y. That relationship is stored as a ML model. We also call it as a target hypothesis or target function or ML model. So you have a ML model now which denotes the relationship between X and Y. That relationship, not X, not Y, but the relationship, how it is stored. So that is stored in as a ML model. Now, when the next time the new image comes, you have a new image now. Again, you do the same kind of processing and you bring into the same format, but it's a very new image, the image which you are not seen yet. It's a new image, but now you apply ML algorithm and you use this ML model, what we had derived before, and you use that for decision making and derive this Y. So it is simple. When you are making computer to understand or train it, we call it as a train, we provide both X and Y and we train the algorithm. So algorithm will now understand what is the relationship between X and Y. That relationship, it will store it as a ML model. Now next time when you actually want to test it, whether it is really giving you the right output or not, that is called as a testing, where you give only the give input X and it has to return you the output Y. Ah, one second. Okay. So this is what is the basics of machine learning. Like, so types of data can be text files, or it can be different types of data, sensor data, images, video files, audio files, etc. So what after processing the data, what we have is the data in this format, which has different features, and this is the label, that is y. This is x, this is x, and this is y. So overall, machine learning actually tries to learn with the data. So it is not the one who has the best algorithm that wins, but it is the one who has the most data who wins. So this we have understood. Now what is actually it learns is it learns a function. So you have a y and you have a x, and you want to learn the relationship between x and y. So we are actually learning a function f. Okay? And that function we represent it as a hypothesis. So it is actually the way how the function can be represented in different format. So what kind of assumption that we are making, what kind of representation it is, we call it as a hypothesis. And we actually wants to learn this, the parameters W1, W2, W3, W4, W5, W6. This is what we are learning, where this Y we assume it is given and this X values are given, and we want to learn this W. So that is all about the basics of machine learning. Now, how to learn a target function? So we have different algorithms: decision tree network, artificial neural network, k-neural. So all these algorithms actually differ in a way how learning is done. So for all these algorithms, we should understand that x is given and y is given, and what is that we want to learn is f. That is same. But how do we learn this here? How do we derive the parameters, these W1, W1, W2, W, how these we define these parameters? That will differ in these algorithms. The way it learns a function f, or the way it learns a function parameters. Okay. So now we'll come to, I think you have got, means many of you must be already knowing these things, but just to set, because if some of them may be new to this concept, because it is an interdisciplinary webinar series where people from different departments are there. So maybe from the technical side, to understand what is machine learning, actually I went through the basics of that. So our research is specifically through the data that we have considered is a audio data. So we have considered different kinds of audio data. Now, as I told you, whether it is a audio, video, text, whatever kind of data, machine learning, what we do is same. It doesn't differ. So what is different is the way you process the data. How do you process the data? How do you bring that into a format which is suitable for the machine learning? That is what is different. So now we have actually worked in the area of Carnatic music analysis. Carnatic music analysis, especially in that, there are three concepts in which we have worked: is a raga mining, instrument classification, and singer voice identification. So here, the data that we have is an audio data. Okay? The data that we have is an audio data, and we do signal processing on the audio data and bring it to a format which is more suitable in the machine learning. Now, what is the objective? For example, if you say raga mining, what we do there? So, given an audio clip, we apply same this AI and ML techniques, and we want to identify in which raga it is played. In which raga it is played. So here the audio clip that is given can be an entire song, but even if it is entire song, because audio is a time series data, means as the time changes the content changes. So what we do is the audio data will be divided into smaller chunks, or smaller, we call it as a smaller frames, and then you take each of these frame and you apply so here diagram is there, sorry for that. So recorded audio files will be there. The first thing is you label the audio data. That means you have one music. Let us say you have one music sample, and it is belonging to a particular raga. Let us say. So now that, see, this is audio data that needs to be processed first. So that needs to be processed to extract the features. But at the same time, so that when you extract the feature, it becomes the data X. And then you also should supply a value Y. So this process is called as labeling. Labeling means, for example, I know that an audio clip belongs to a raga, let us say Mohana raga. Now, Mohana Raga, how does a computer identifies that it is a Mohana Raga? Means how does it gives an animation? So some numbering has to be given. So we can have, for example, for Mohana Raga, we can always say it is numbered 0. So that 0 is the identification for this. And like that for Kalyani Raga, you can have it as label as 1. So like that for different ragas, you you have a corresponding label for that. That process is called as audio data labeling. So for a given input, you need to identify. So you have a set of recorded audio files. For each of the audio files, what is the raga it is, we should know in advance. Why we should know in advance? Because we want the computers to learn from the examples. So that examples given will be in this format, X and Y. And this Y will be the labels and X will be the features. Now, the special thing about this, when it comes to audio data, the special thing that we have is how do you process the audio data? So how do you process the audio data is a signal processing technique. Now in that, these audio data will be divided into audio frames. So you have a audio data which is a time series data, because this is not a very simple technique to explain in actually in short time. But I had done one webinar FDP or natural language processing, where I have given a very detailed analysis of what are the kinds of features are there, and how you extract those features, and specific to audio and kind of data, how exactly feature extraction is done. So here I'm just giving a brief idea, like you have an audio data and you need a signal processing technique there. So your audio data, that when you read the audio data into your program, it is actually nothing but a signal. It is a series, time series data. So you divide that data into smaller chunks. We call it as a frame. So this is one frame, this is frame 2, like that. So all these frames belongs to the same music, same input. Okay. Now you take each of these frames and you extract feature from that. So what kind of features we have we can extract from audio data? Like we can have a feature like MFCC, mel frequency substral coefficient. We can have a feature like LPC, linear predictive coefficient. We can extract features like pitch, or just spectral related features, spectrogram, all those kinds of features which are related to signal processing techniques. We can extract it. And once you extract, for example, you extract a MFCC feature of this frame, and then you extract a MFCC feature of this frame. Like that, you extract MFCC features from all these frames. That becomes your data X. So here, and that data will look something like this. So finally, every input that we have has to come into this format. So this is your feature. So instead of spatial length and all, you have the coefficients: MFCC coefficient 1, MFCC coefficient 2, MFCC coefficient 3, like that. You have the different MFCC coefficients, and you have the labels as this is raga. Let us say this is Mohana raga, this is Kalyani raga. The labels will be like this. So the labels, corresponding labels indicates which type of raga it is. So what you need to learn is, let us say these are the MFCC coefficients. You need to learn if this is Mohana raga, what kind of features you will see here. So you have to learn the mapping between this value and this value. So that is done by the machine learning, and different algorithms. We can use same kind of algorithms, like we can go for artificial neural network or support vector machine, which is that we have used. So artificial neural network will bring what will define the features with nodes, that is neurons, and we need to define the structure of the artificial neural networks. How many inputs are there? Let us say if we have 12 coefficients, MFCC coefficient, we can use 12 neurons in the artificial neural network, and one output that denotes which raga it is. So that is one of our work, which is raga mining, where we identify the label given a music audio clip. We identify which raga it is, in which raga it is played. Similarly, instrument classification. So given an audio music, which instrument is played, What kind of instruments like sitar, veena, flute, mandolin, saxophone, like that? What kind of instrument is played in that music? But here we have not considered a different like polyphonic type of music, just a simple single, which the musical audio which has single type of instruments inside that. Such kind of data we had considered. Then we have one more area, that is singer voice detection identification. Who is the singer? It is like speaker identification. So who is the singer which is singing the song? That so again here the complexity of this application increases with the complexity of the kind of data that we have. So data that we have is, if it is polyphonic, lot of background music is there, then you need to extract the voice of the singer from the voice, that is vocal information from the audio, and then identify which singer it is. Similarly, another area in which we have worked is the animal and bird sound recognition. Again here the sounds that we are taking is different sounds of the animals, so which we collected through internet and different websites actually, which provided the animal sounds and bird sounds. This application is comparatively easy. Why? Because the duration of the data will be very small. Like you just need 1 second or one half a minute of audio clip is enough to identify which which animal it is or which bird it is. But when it comes to raga mining, that is not enough. At least 1 minute of music has to be there, so you need to process this entire 1 minute of music and identify the features, and that features collectively should represent one raga. So like that. And even in case of instrument classification, you can just identify with a very short amount of data. Even with a singer voice identification also, it could be done with a short amount of data. So speech recognition is another area which we have worked on. Speech recognition is so they see all these applications, the objective will change. Speech data means what kind of, when the speech data is uttered, so what kind of word is spoken, you need to identify what is the word spoken. So what we need to identify will differ. All these are audio data, but what we are looking for will differ in this raga mining instrument and singer voice and animal bird voice, and also speech recognition. So what kind of word or what kind of akshara, what kind of sentence is spoken. So we have worked in akshara and word level. We have taken the data set for Kannada language utterances, which was actually collected from different websites. Again, Triple IT and IIT Madras, which they have they had published their own, not a very big data set, but we had used that to work for our research work. And currently, we are working in these two areas, that is voice disorder analysis and detection and speech therapy. Again, speech therapy is a kind of, what is speech therapy? So, when a voice is given, example. So, when a voice is given, that voice may have some problem. It could be a normal, healthy voice, or it could be an unhealthy voice. So you need to identify, for example, what kind of, it might be that unhealthiness in the voice. Maybe like someone is not able to speak properly, or someone is speaking with a very low pitch, or someone will have some problems physical in the what voice organ. So such kind of problem, so what usually doctors will do is they will record the data, and they will sit and they will analyze the data. They will hear it with perception, they will analyze, and they will try to identify what kind of problem it is. There are different kind of speech voice disorder problem which occurs, and they will treat for that voice disorder based on the kind of problem. So that detecting the kind of problem is one thing. Like there is a need to be so many times patient has to visit the doctor, and doctor has to record it every time, analyze it, listen to it, analyze it, and do so many things to identify exactly what is the problem. Now, can we automate that process? So can we make an automated voice disorder detection system which will take this diagram is actually for that, take the voice sample and identify what kind of problem it is. Again, the kind of features that we may use may be with the same set of signal features that we have. Okay. So but what kind of, for example, some of the application MFCC may be very useful, for some of the application LPC may be useful. So what kind of features are useful for that application, that we may need to do some trial and error, and we may need to derive that. Now what kind of study that we need to do is what kind of, like, how many types of voice disorder problems are there, and when you take the speech data, which kind of problems it is. If we have enough example for that, we can train the algorithm to learn what kind of problems will give, what kind of features will be there in a for a particular voice disorder problem. So to do, and also so there is a speech therapy. So one thing is voice disorder analysis and detection. Another thing is speech therapy. Therapy means you diagnose the process, means you treat it. So for treating, again, there is one is like you give some maybe some operation need to be done, or some kind of medical supplements need to be provided. That is one kind. But there are some kind of voice disorder problem for which we need to train the user. Like we need to continuously make them speak. Okay, so a patient has to go to the doctor repeatedly. Doctor has to train the patient to speak a particular word or speak a particular akshara. For example, patient is not able to speak akshara r, or sir. Sir is pronounced as sh. Sh is pronounced as such kind of problems may be there. So continuously the doctor has to provide the training. That is, continuously monitoring has to be there. So could that be avoided with the interactive application? That is what is speech therapy. So in speech therapy, what we try to do is you take the data from the voice sample from the user, and you identify what kind of problem it is it a normal or is it not a normal voice. If it is not a normal voice, a response has to come from the computer algorithm saying, guiding the user to utter the word properly. So the continuously monitoring will be done by the algorithm instead of the doctor. Means doctor will do some kind of monitoring, but that continuously monitoring will be done by the speech therapy application. That is what is speech therapy. So another thing is natural language processing. This is recently we are started in the working in that. So I'm not going to explore much on that. So it is like the data, kind of data that we are taking is from the healthcare, and we are trying to apply NLP. So for all these, this is currently we are active in these research areas, and we also have established a lab for this, like, which is funded by the VGST Government of Karnataka Center of Excellence for Natural Language Processing and Speech Disorder Detection, specific to Kannada language. And as a part of that, we have also applied for the establishing soundproof studio for that, and which has been already like given, and it has already been inaugurated. So the main purpose of that lab is to, we want more data to collect. We want to collect more data and create a one benchmark data set for the application related to this voice disorder analysis and speech therapy. So such kind of patients take their data, or small kids who face problem in speaking. We Our aim is to bring them here and collect data as much as possible and make them a standard data set, so that it will help for our research work. So this is all about our research work. And to tell, see, all these research work to explain in detail, it needs lot of speech signal processing technique, that is domain knowledge in the background, which is not possible to explain in this short duration. But as an application, all these applications are machine learning application, and that's why I just explored on what is machine learning, because if finally what we do here in all these applications is find out that f, that is function f, which maps x and y. But what x you are giving, that is where you do the research. Means depending on what kind of application you are solving, what is the input that you are giving to the algorithm. So one thing is you do the research in that, how you simplify your input. Another thing is Once you generate the input, how your machine learning will solve the problem. So some fine tuning there, some fine tuning in the way you find out the function that is a target hypothesis. There could we could do more research. And if we are using deep learning instead of machine learning, so the difference between machine learning and deep learning is in this part where we don't have to extract this feature. So what we can do is directly, whatever data comes, we can directly start generating the ML model for that. We don't need to extract features. We don't need to extract, this has to be done. So whatever raw audio data is there, don't do processing. Directly find out the mapping between the input and output. For example, if the image is there, you take it as a sequence of pixels. Don't see, okay, what is the color, what is the texture, how is the edge, all those features you don't extract. Just give it as a sequence of pixels. If it is audio data, just give the sequence of samples. Whatever is it, just give it as it is to the deep learning. So deep learning will take care of learning the features internally and providing you the output. So that is all about the basics of research applications, the basics of ML, and our research work, what we have done specifically in this area, that is um, audio data, related to audio data, how machine learning is connected with the audio data. So with this, I end my presentation. I thank organizers for giving me an opportunity and all the audience for being with me. Thank you.
Thank you, madam, for a simplified yet effective presentation on the basic concepts and sharing your work related to audio data processing. Audience, we are open for questions. If you have any questions, you can raise. You can just put in the chat section and any questions from the audience? Okay, if there are no questions, then I think we can move on to the next session. So we'll go with the next session now. It's a privilege to introduce to you our second speaker for the day, Dr. Rashmi P. Shetty, who is currently working as the assistant professor in the Department of Mechanical Engineering, NMAMIT Nitte. She received her PhD from NITK Surathkal in the year 2019 and secured a gold medal in MTech from NMAMIT Nitte in the year 2012. She has around 12 years of teaching experience. Her areas of interest include renewable energy and artificial neural networks. Dr. Rashmi P. Shetty is here today to share her knowledge with us on the topic AI current trends in mechanical engineering. Over to you, madam.
Thank you, Nikita. Good morning, everyone. So I'm here to present for the topic current trends in AI. So as we all know that in the recent years, the AI and ML is gaining a lot of momentum because and it is moving from the hype state to the actual application, because all the corporation sector as well as the industries are trying to use and apply it to their actual practical problems. So the mechanical engineering being a specific industrial field which deals with the design, implementation, analysis, giving exciting approaches and opportunities. So by making effective use of this machine learning and artificial intelligence, the area of our mechanical engineering can have new approaches for data analysis and can develop more novel and good quality products at less cost, with less time and with less defects. So um, because all the manufacturing industries are now moving towards the automation in a larger way. So the artificial intelligence and machine learning is becoming one of the uh, have to the mechanical today's mechanical engineering should have the skill of machine learning. So as a department of mechanical engineering, we are offering many elective courses to our students, such as introduction to machine learning, cognitive computing, and AI and expert systems. And our students are also showing much interest in all these topics. So, since my research area is the renewable energy, and we have a group in our department who are working for various different fields of research in mechanical engineering by using various artificial intelligence tools. So I'll be exploring all these applications of artificial intelligence for mechanical engineering research fields. So I'm presenting my screen. Hope my presentation is visible. Yes, thank you. So by using artificial intelligence in a proper way, as I told, it can benefit largely the mechanical engineering field with the better analysis of data, and we can improve the production process by taking better decisions. So one of the approaches and main applications of artificial intelligence can be seen in Industry 4.0, which we can also call it as a fourth industrial revolution, which integrates the AI with the industry. So
Ma'am,
here the
excuse me.
yeah.
Ma'am, could you please put it in the presentation mode or the slideshow?
Yes. Yeah, now is it okay?
Now it's fine, ma'am.
Thank you. So AI is one of the basic concepts of engineering industry 4.0, and it is a key technology which is being increasingly researched and applied in factory digitization. So what happens in industry 4.0 is there will be increased use of the sensors and embedded systems, and there will be again the use of connected devices such as internet of things, and there will be networking and horizontal and vertical networking. So all these will lead to more flow of continuous data. Okay, so continuously data will be generated. One more thing I would like to tell is whenever we use artificial, whenever we look to solve some problems using artificial neural network or ML, the data is a must. So good quality data, when we have a good quality data, only then we can solve any of the problems using these techniques. So with a modernized industries where we have a lot of sensors to capture the data in a continuous manner. So the industry experts feel that they are sitting on a large pile of data today, and if this data is used in a proper structured manner and in an integrated way, then we can arrive at optimal process control. So, as I told, we have a group of people working on artificial intelligence under the able guide of Dr. Srinivasa Pai. So, I'll be just touching through all these areas of application in mechanical engineering. So one of the application is machining application. So the engineers are facing a lot of problems in machining processes, manufacturing processes, because they have a limitation of the raw material, the kind of raw material they have, the kind of resources they have. So it is a very challenging task in front of the manufacturing engineers in order to increase the productivity and develop a good quality product with less cost, less time, and with less defect. So whenever these problems are faced, the artificial intelligence, so and in order to improve this machining processes and manufacturing processes, they have to select proper parameters. Okay, machining parameters. So selection of proper machining parameters takes a lot of skill and experience, and it has many factors affecting to improve the process. So it is a difficult task. So the researchers are trying to propose the models which can simulate the experimental condition of machining. So during machining, what are the conditions affecting the machinability or maybe the quality of the product? So we can have a simulation to simulate the experimental condition, and the artificial neural network have been successfully applied in order to predict the relationship between these independent and response variables. That is, the input variables, the conditions which are affecting the machinability, and the output is what type of, what quality of machining is being done. So the particular field of research that is focused here in our department is machining of difficult to cut materials such as titanium alloys. So these have specific applications, and these materials are expensive. And due to poor machinability, the cost of machining also will, production cost also will increase. So the aim is to select the proper parameter and condition of machining, and optimization of all these things in order to decrease the production cost and increase the productivity, and also achieve high surface finish. So again, one more thing is, in all our many of the research topics what we take, we have tried to hybridize the artificial neural network (ANN) models with meta-heuristic optimization algorithms, because in order to maximize, as we have seen in operational research, maybe in order to maximize some objective function, maybe the production or productivity, we can achieve with the given constraints by optimizing some of the parameters, input parameters. So here the optimization of the machining parameters, such as the cutting speed, the feed rate, the depth of cut. So all these optimize the machining parameters are tried to optimize in order to achieve a good surface finish with less wastage of material. And here, different artificial neural network techniques such as multi-layer perceptron neural network, radial basis function neural network has been implemented in order to model and predict the surface roughness parameters. This is one of the areas. So this the content has been presented from this particular publication. The next interesting area is the computer vision application. So here, the artificial neural network has been used in order to, identify some of the images of the machined surfaces. So there are different machining processes we use. Maybe it is turning, it is grinding, or it is shaping. So once the machining has been done, the image once it is I mean image will be captured, and it will be then classified into the various classes, whether it is this was the turning, it is whether it's turning or it is shaping or it is milling or any grinding processes based on by using the artificial neural network. So this is the experimental setup which will help you in understanding how is artificial neural network applied. So here we use our digital camera in order to capture the machined surface picture of the surface machine surface with the help of a proper lighting source, and PC is used, and we use in order to extract the features. In order to extract the feature for the recognition of the machined surface, wavelet transform has been used in order to extract the features, and then MLP and other neural network techniques have been used in order to classify the features by using binary scheme of classification. So as shown in this second sketch, you can see. So there are many features, as you can see, which are extracted by the wavelet transform, and the output, say it is 100. If it is a turned surface, it will be 010. So this is labeling. Okay. So 010 for ground surface, and 001, that is for shaped surface. So once we provide the labeling for whatever images we give to the algorithm, it will try to learn from those labelings, and then it will try to classify the test. If you give a new image, it will try to classify into which type of machining has been done. And here, this particular presentation, whatever content I have presented, is from this particular publication. So next is IC engine applications, internal combustion engine. So whenever you hear about mechanical engineering, the first thing that comes into your mind is the internal combustion engines. So a lot of research work is going on in this field, and even in our department, a lot of work is going on, because the conventional fuels, depleting fuels, in order to use alternate fuels in place of the conventional fuel. So the ethanol blending, some of the alternate fuels are blended. So a lot of work on alternate fuels also is going on here. So the people are using CNG as a blend, and ethanol as a blend, waste cooking oil as a blend. And now, the what is the objective of the research related to IC engine? So we want to get maximum efficiency out of the internal combustion engines, and we want to reduce the emissions. So there are two objectives here, because the pollution is a major problem here. So we have to aim on the efficiency as well as to reduce the pollution. So again, we want to model how is the depending upon various parameters, input parameters, mainly as shown here, the what is the load, what is the fuel, what is the percentage blend, what is ignition timing, compression ratio. Depending upon all these input parameters, how the efficiency factor is varying, and how the emissions also is varying. And by optimizing some of the input parameters, how efficiently we can increase the efficiency, and how we can decrease the pollution. So the researchers are using various optimization algorithms in order to optimize the input parameters. So this is the publication on this particular IC engine research work. So next, very exciting or interesting field is condition monitoring application. So what do you mean by condition monitoring? So it is the process of assessing the health of a system. So any system over the usage, it requires maintenance. So maintenance will cause some problems because it may break down and the machine may not be available whenever required, so it may reduce the efficiency of that particular instrument. It may cause many other problems, vibrations, noise, or any such things if it is not properly maintained. So before breakdown of the machine, if you can do preventive measures, if you want to take the preventive measures, and continuously if you want to measure the health of that particular instrument or any mechanical system for that purpose, so that is called as a condition monitoring. So we have a test rig here. In order to do the test rig, which has a bearing setup, um, customized bearing test rig in order to acquire the raw bearing vibration signals. So there are four conditions for a bearing, that is whether the bearing is normal and working, or whether it has the defects. Where the defect exists, the defect can be on the inner rays of the bearing, in the wall of the bearing, or it is in the outer rays of the bearing. So it is a signal processing. Okay, here we get the vibration signal from the test rig, and that vibration signal is used to check how is the condition of that particular bearing. Okay, so here again, whenever I speak about the signal will have noise, so which is unwanted, so it will deteriorate the accuracy or performance of the AI model. So before I feed it into the AI in order to generate the prediction or classification model, I have to remove those noise. So in here we use the wavelet transform for signal denoising, and then wavelet transform is also used for feature extraction. So you can see this signal flow diagram, or the block diagram, where we get the vibration raw signal from the test rig, and that signal will be then sent to wavelet denoising. The unwanted noise will be removed, and then the wavelet transform is used for feature extraction, and then it will then fed into the AI model, where it will predict what is the health index, and in what class it falls, whether it is having any defect or whether it is normal, where is the defect, etc. So that corrective measure can be taken, and it will help in reducing the maintenance cost, as well as it will improve the productivity with the improved machine availability. So that's how AI can help in condition monitoring, and this work is based on the publication shown here. So next is my research work, that is to predict. So my research work is basically on wind power modeling and wind speed forecasting. So since a lot of importance is now arriving for the renewable energy sources due to depletion of the fossil fuels, as well as there is increased pollution. So there's a lot of importance to the renewable energies, and wind energy is one of the competitive resources which is clean, and hence there is a lot of research work going on in this direction. So what is the main problem with wind energy is it is intermittent in nature. Okay? We don't have wind in a continuous manner, in the sense at what speed we want it to be. So it is stochastic, and it is intermittent in nature, and with this creates a lot of bottleneck in order to integrate it with the available conventional grid. So and the wind turbine manufacturers will test the wind turbine under standard conditions, and they will provide what is the power output from a turbine for this particular wind speed. So for various set of wind speed, they will give what is the power output of a wind turbine. But the actual working condition of the wind turbine is quite different from what those standard conditions. So we need to have a proper, site-specific power prediction models by considering the actual working, okay, actual working condition of the wind turbine, so that it can give us answers, and it will help in proper grid planning, scheduling, and large-scale penetration of wind power into the energy market. So integration of the wind energy with the existing power can overcome all the difficulties by having a strong model. Okay, so AI artificial neural network can has been proved to be efficient in modeling this wind power. And this wind speed also, it is variable in nature. It is affected by many unforeseen factors, such as it is affected by the rotation of the earth, it is affected by density, then temperature, pressure gradient, and the terrain in which terrain the area. So all these factors affect the wind speed. So if I want to forecast the wind speed, it is very challenging task. But AI has been successfully used in doing the wind speed forecasting also. So in my research work, I've used the popularly known two techniques, that is multi-layer perceptron neural network and radial basis function neural network, and the learning algorithm. So how we make the neural network model learn. So a very popular learning algorithm is backpropagation learning algorithm, and the newer one, the considerable, the new technique, that is extreme learning machine algorithm, has been used. These two are the popular batch learning algorithms. What do we mean by batch learning algorithm is whatever. So when we have the data, we split it into a training and test set. So that training set, if you give it at once, okay, one go, all say I have got 100 data, in that I split it into 85% training and remaining 15% test. Okay, so if I'm feeding all that 85 data at once, then that is called as a batch learning algorithm. But wind energy, it is a real time, it is online in nature. So the wind data is received one by one or chunk by chunk, continuous manner. So what we thought is, why don't we use online learning algorithm? So we used online sequential learning algorithm, which is more suitable, because the batch learning algorithm, we have to store the data, and there will be it requires lot of storing effort. So by using online sequential ELM, we can overcome all these difficulties. And as I told, we have done many of hybridization type of work in all these areas what I spoke now. So in all the areas, we try to do some hybridization. So the hybridization can be with respect to, if we can see the hybridization in literature as follows. So we can combine different modeling techniques. Okay, we have a statistical modeling technique, we have ANN. So with respect to wind application, if I speak, I have a statistical model, that is ARIMA, that is moving integrated method. So where I can use that ARIMA also, and I can combine ANN. So both will have some advantages, some disadvantages. So by having the different models, I can utilize its advantage than a single model. So that is combining of different modeling techniques. Next, we can have a combination of data pre-processing techniques with a modeling method. So in some of the applications, as I told, there's a noise, we have to reduce the noise, we have to do, okay. So those are the data pre-processing. So how we can improve the quality of the data before providing it for the modeling technique. So how exactly I combine this data pre-processing technique is one of the hybridization method. Then combining different models based on weights. Okay, so Bayesian model averaging is found to be the very popular and widely used techniques. Then coming to the optimization algorithm. So optimization algorithms. we see a lot of meta-heuristic optimization algorithms nowadays, which are based on the natural processes. Okay, to name a few, we have particle swarm optimization, we have cuckoo search, we have got artificial bee colony. Okay, we have number of such meta-heuristic algorithms which are found to be very suitable for non-differential, non-linear type of problems, real-world problems, which are extremely difficult otherwise to optimize by the conventional optimization algorithm. So these optimization algorithm can be effectively used maybe in order to optimize a feature selection, or maybe in order to optimize the input parameters, as I gave some examples there. So in case of IC engine and all, how effectively you can optimize the input parameters, say the what is optimum blend if I'm using diesel as well as I'm blending it with some alternate fuel. So what is the best blend in order to get high efficiency and reduced pollution. So in that way we can use optimization algorithm, or again we can use the optimization algorithm for optimizing the model parameters. What are model parameters? So whenever I select a particular model, I have to design it. I have to select what are the number of hidden neurons and various other simulation parameters. So it will take the expertise of artificial who is designing that particular model. So in order to overcome all those limitations, why do we need to wait for some expertise? So why can't we use optimization algorithms to select those model parameters which will give a good accurate result? So this is coming to my work. I've divided my done my work in three different ways, but I'm focusing mainly on only modeling here. So of course I did tried various conventional models, and of course ANN models proved to be better than the conventional models. So in ANN modeling, I tried, as I told, MLP and RBF, and I tried different learning algorithms, that is backpropagation, gradient descent, and ELN. And in that, I'll come to it later. So, input feature selection. What are the input parameters in order to best model the output? Say my whatever I focused in wind turbine power output. So, in order to get or predict power output, what are the influencing input parameters? Selection of that influencing input parameter becomes a very important step in designing a neural network model. So once it is selected, we want all those data. As I told, data, whenever if you don't have the data, you can't go ahead with your research. So the data collection for my research has been done from a supervisory controlled data acquisition system from a large wind farm that is located in the central dry zone of Karnataka. And there is a 10-minute average data I took for 6 months. The type of the turbine was a horizontal axis wind turbine of capacity 1.5 megawatts. So then once I get the data, then I have to do the pre-processing. So there may be missing data, there may be not sensors, maybe there may be failure of sensors, the errors in the data that have to be removed, and then the data has to be normalized. So, okay, so when we have the data in numbers, we have to normalize it to bring down the data into a proper common range, that is between -1 to 1, or it can be 0 to 1, so that each of the data contributes equally in development of the neural network model. So this is again a very important step in developing a neural network model. So I have followed this particular method, that is x minus x min divided by x max minus x min. So where I had, this is the sample data set I am showing. So out of these, all the columns, I searched for what is the minimum value, what is the maximum value. Then I use the previously shown equation to normalize it so that I can overcome the negative values also. So I took 2,966 data set. In that 85% I took as training, then 15% as testing, and then 5% for validating the model. I used MATLAB software, and we need to have identify some performance metric for grading the models, or to see how accurate results it is giving, and you want to compare it with others. okay, other modeling methods what people have used. So you need to have a proper performance metric. So root mean square error and mean square error has been considered as performance metric, and the mean square error for defining the accuracy of power modeling, I took mean square error of zero point zero 0.01 kilowatt square as a acceptable limit. Now, as I told, I use multilayer perceptron. So let me briefly tell about how is multilayer perceptron neural network working and what are the basic characteristic feature of this. So here we have, as we know that the neural network there are many layers. It uses many layers. So there will be input layer and one other one is the output layer. Input layer is the one into which it is in contact with the environment and we are providing data. It is collecting the data from the environment. We provide input values, and between input and output we have hidden layers. So because it is a multi-layer perceptron, there are multiple layers can be possible. Multiple hidden layers are possible in this particular type of architecture, and between the input and the hidden layer there will be, it is a fully connected layer. Okay, there is a fully connection, and there are weights and biases between the input hidden and the output. um, and there is a nonlinear activation function, that is sigmoidal activation function, used in the hidden neuron as well as in the output neuron. Then one more technique I used is a radial basis function neural network. So here learning is somewhat different than that of the multi-layer perceptron. So here it has only three layers: input hidden, only one hidden layer, and one output layer. So here the learning is finding out a surface in a multi-dimensional space in order to suit the such like the curve fitting, the curve fitting of the training data. So the hidden layer of RBF neural network consists of the Gaussian activation function, um, and there are weights between the hidden as well as the output. So what happens during training? So training means we give input as well as output data. Okay, so when we give input and output data, it has to learn from the data set, that is x and y. I'm giving x, this is input, this is output. It has to learn from the data and then it has to adjust these weights and biases. I'm showing the connections, weights and biases, and it has to adjust the weights and biases. And for that, we need to have a learning algorithm. So in RBF neural network, we can improve the performance of RBF neural network by having designing using various learning strategies. So how it is based upon how you are fixing the centers of RBF neural network. So we have different methods: fixed center selected at random. I've tried various different center selection algorithms, and I found that there is an improvement in the accuracy when I'm going for a better center selection algorithm. So again, you can see that there is a meta-heuristic algorithm, PSO, that is combined with the FCM, fuzzy C-means clustering algorithm. So that's been found to be a best clustering algorithm. Then, as I told, the neural network should be made to learn. So there should be a learning algorithm. So backpropagation learning algorithm is a very widely used learning algorithm, which is iterative in nature. So what happens when I give during training, I am giving the input as well as output. So once in the forward pass, it will calculate, say, there will be randomly generated weights and bias. So it will calculate the network output. Say it is O is the network output and Y is the actual output. I have input, say X, I have output, say Y, and O is the network output. So what it computes is what is the error. Okay, network is giving some output, and what is the error between the actual output as well as the network output. So once I find the error, this actuates the control mechanism for this backpropagation learning algorithm. Now the signal will pass in a backward manner and the synaptic weights will be adjusted. Okay, So the learning is now taking place. Depending upon the error, the weights, these are the free parameters in the neural network, the weights will get adjusted. And here we follow it follows a delta rule as given in all these equations. So weights will get adjusted. So initial new weights will be developed depending upon the old weight and how much is the error. And this is the iterative procedure, and there are a lot of problems here. It suffers with local minima. Sometimes it gets stuck with local minima problem, and hence there is a it takes a lot of time also for training. It needs thousands of iterations. So we tried a new very interesting algorithm, that is extreme learning machine algorithm. So it uses only one epoch or only one go. In only one go, it will try to find out the best set of weights. Okay, so here the Moose-Penrose inverse generalization, inverse method is used, and this inverse operation is applied to the hidden layer output, that is H. You can see the hidden layer output matrix as H. So this particular inverse operation is applied to the hidden layer output in order to find the output weight matrix. What I mean by output weight matrix, weight matrix between the weights between the hidden layer as well as the output layer. So in order to find that output weight matrix, it uses only one particular step. It inverses the hidden layer output. So these are the various models we developed based on various combination of the center selection algorithm for strategy for RPF, and the various learning algorithms, BP and ELM. So I thought it will be interesting to show you one of the result by comparing gradient descent BP and ELM. So this is for the RBF, radial basis function neural network with condition FCM, CFCM. So here you can see that the best result for BP based algorithm is achieved for centers of 1025. And you can see the next table where the best result was obtained for only 50 centers. So the architecture, the for neural network architecture becomes very simpler when it comes to ELM, and you can just observe the time taken. So time taken for ELM model is only 0.56713 seconds, but the other, that is backpropagation algorithm, took nearly about 24 seconds. So there is a considerable reduction in the time taken during learning by using the ELM algorithm. So there has been found to be a good accuracy also when we used ELM. So these are the publications on that particular work. So finally, trying to conclude is, so this is one of the case study. I found it in this particular research paper where they are trying to do artificial intelligence for industry 4.0. So as you have seen that a lot of research work is going on in our institution, and we are able to publish a lot of good quality papers also. But we have some barrier, and we are not applying it for actual practice. So what this particular paper, what people are doing, so there is a spindle, machining spindle. It is trying to provide a full solution for real-time monitoring and performance prediction of a machine tool spindle. So somewhat similar to whatever I spoke, that is condition monitoring. Okay, so here it is monitoring the machine spindle, and there are the sensors which will the data acquisition takes place, and this data that has been acquired from the machine is then sent to from the physical space, from the factory space floor to the cloud. Okay, from the physical space to the cyberspace, and then it will get converted into some critical component, into some useful information. And there are data driven modeling which uncovers the hidden patterns in that particular data in order to develop the unknown correlations, it tries to get the unknown correlation from manufacturing system, and this whatever it tries to get the generate the health index. Okay, how is the machine machine spindle, whether it is proper, or is there any malfunctioning there. So it is trying to generate that particular health index, and then it will give back to the maybe the operator there, that is something there going wrong, and based on the health index, the better decisions will be taken in order to make the corrections, or now one more step ahead in for industrial 4.0 is there are no operators, and there are multiple machines which are themselves integrated, such that machine to machine collaboration is there, and they themselves will adjust the production based on the availability of machine. So how much which machine has to produce which, how much, depending on its condition. Okay, so this is how the industry's expectation and future scope, future industry will be. So there should be what I'm trying to tell is we are doing a lot of research, and there should be some there's some gap between the industry and the institute, and there should be some bridge connecting the academic research and industry applications. So there is a lot of hope for the industry. On the expectations are very high on the in the industrial level for machine learning. So then we can bridge this gap between whatever research we are doing and how we can apply into actual usage. So if that happens, that will be very much a good development towards the future industry in India, maybe. So there is an urgent need for systematic development and implementation of AI to use it in real world applications for next generation industrial systems. So thank you all. Thank you the organizers for giving me this wonderful opportunity to share my thoughts.
Thank you, madam, for sharing your insights on application of artificial intelligence in mechanical engineering. Thank you so much. Any
Thank you.
questions from the audience? Okay, then if there are no questions, I think we can move on to the last session for today. So the last but not the least, I take pride in introducing our next speaker for the day, Dr. Ashwini B., Associate Professor, Department of Information Science and Engineering, who will share information about AI project development using Nvidia server. Dr. Ashwini B. received her PhD from VTU in the year 2019 and has 16 years of teaching experience. Computer vision is an area of interest. Over to you, madam.
Thank you, Nikita, for the short and sweet introduction. Good morning to all. Let me share the screen first. Okay. Sarika madam and Dr. Rashmi ma'am have given you an insight on what is AI and what is ML. So I would be talking more about the infrastructure what we have for working with the AI and ML algorithms. Okay, Nikita, hope the screen is visible there.
Yes, ma'am, it's visible.
Okay, thank you. So our college. Okay. Our college, we have purchased a NVIDIA server, okay, which is purchased by the ISC department of NMAMIT. And this NVIDIA server is basically purchased in view of the growth in the AI and ML projects. As AI and ML projects do require training models which work with the large amount of data. So data can be your text data, or it could be your images or audio signals. So any kind of data, it could be very huge, because you would be training your model with your huge data set. Okay, so working with huge data set in your laptop, it would not be sufficient. Maybe for training the model, your laptop would just go get stuck at some point of time, uh, if you do not have a GPU facility in your basic versions of the laptops. So looking at these growth in the AI and ML projects, the IS department and the college decided to purchase the deep learning server. So basically, in this deep learning server, we have two GPUs. So we have two Nvidia Tesla P100 GPU, which is a very basic version, actually 12 GB. Of course, with the demand in the AI projects, um, within 2 more years, we would be updating the GPU cards also. But then, of course, for the college set of projects, and for doing any kind of experimentations with your AI and ML algorithms, this two GPUs is more than sufficient. And we do have a major advantage in this is we do have a 3600 course here, which makes the running of your AI and ML algorithms very fast. Okay, so that's the basic advantage of having an Nvidia server in our college. And many of the researchers in our college, and also the students, do train their model with this Nvidia server. Okay, so and this Nvidia server provides all set of recent platforms, like say TensorFlow, Cafe, or it could be your Microsoft SDK. So there are various containers available in this particular server, through which you can implement your AI or ML projects in a faster way. Okay, you need not depend on your laptop, or you need not buy a laptop for with a very good configurations to work with the AI and ML projects. You can always utilize the Nvidia server to do this. Okay, but before using this Nvidia server, there are some few basic things which we need to understand, because here when you're working with our server, we have Dockers installed in the server. So the first thing, whenever a student or a faculty gets an access to the Nvidia server, they would be knowing about the AI and ML, their algorithms, the packages which they have to install, and all these things they would be knowing. But the problem is they would not be knowing how to start in the server. Okay, as we have Dockers in the server. So I thought this could be the platform where I can tell you how we can use Dockers to basically implement your AI and ML algorithms in the NVIDIA servers. Okay. Basically, say initially we consider you are developing an application. Okay. Where you would be having application depending on a specific operating system. You would be having certain softwares which or the tools which which will be used for developing the applications, and there would be some third-party libraries. Okay. So what happens is, if a developer has to develop an application looking at all these constraints, this environment setup has to be there in his machine. Okay, so any kind of applications, you need to install those tools or third-party libraries or dependencies on your machine. So that is what the actual scenario was before. Okay. But then what happens, okay, now the developer installs all these third party libraries, the specific OS, whatever is required for that developing an application, the tools, extra tools, or the softwares required. But then what happens is, now see, the same application is developed and it has gone for testing. Now, when the tester has to test this application, again the same setup has to be given in his particular machine also. Okay, so that could be a problem. Also, say imagine, say the developer, there is a new developer who has joined in that particular group. Again, to use that particular application or to add or improvise the application, again the problem is the same setup is required. Okay, so developers used to run the code on their system. It would run perfectly, but the same code did not run on the operations team system, because of course the configurations or the environment setup, whatever is required for that application, was missing. So this was a tedious task. Okay, installing the same environment wherever you want to run that application is a tedious task. Of course we do have Dockers for it, where Dockers are nothing but the tools or the softwares which enables the containers to run. So containers is not a one second. Okay. Docker is a computer program that performs operating system level virtualization, also known as containerization. So Docker is basically used to run software packages called containers. So container is not something new to us. Okay, it was a pretty old concept, containers. But then previously, running containers was a tedious task without the Dockers. So Docker has made the life easier to run the containers. You would say that, okay, then we do have virtualization. Okay, now say we have VirtualBox where we have Windows, and in the VirtualBox we run Linux operating system, and then we it is something like a Docker. We could say that what is the difference between the virtualization and the Docker here. So in virtualization, what happens is, virtualization is where your VirtualBox would be having the guest operating system. So you have a host operating system, and in the virtual machine architecture you would be having the guest operating system also for each of your applications. And you have a hypervisor which manages these VirtualBox with the host operating system. But then in the Docker, as you can see in this diagram, you do not have a guest operating system. So Dockers actually use the host operating system itself. Okay, so that is the main advantage of having a Docker with respect to virtualization. So as you can see that as virtualization requires a guest operating systems, it could be heavy, whereas Dockers do not need a guest operating system, so it is very lightweight. And also when you go with the virtualizations, it occupies more space than the Dockers. Okay, because of course the resources are many in the virtual machines, but whereas in the Docker architectures, the resources are less, as you do not have the guest operating system. And also the time required to boot the virtual machines is more when compared to the Dockers. Okay, so that is how we thought we could have Dockers in our NVIDIA servers. So each user will be given a Docker. Okay, and inside this Docker you will have a container engine. So that is, you would have a containers. So now in this containers, you can basically run the images. So Docker image is something like a read-only template that contains a set of instructions for creating a container that can be run on the Docker platform. So these images are used to run the containers, and containers are nothing but the static. It is just like something like a suitcase where you fill all the materials. So simple container is nothing if you do not have a Docker images. So now in this container, any user can pull down the images and execute the AI and ML algorithms. Okay. So to do that, a basic set of commands have to be known. Okay. Let me give you a demonstration of it. Okay, so now I'm using a Linux machine here. My host OS is the Linux operating system. You could use these NVIDIA servers in your Windows operating system also, but then you should have certain platforms to it, wherein you can connect the SSH. Okay. So one of the basic advantage of having the NVIDIA server is you can use, or you can implement the AI and ML algorithms in the college. If you are a student or a faculty at NMAMIT, you could use it in the college as well as outside the college, and also other faculties or other researchers, whoever wants to use this NVIDIA server, they can utilize this NVIDIA server from the place where they are working. Okay, so we do have a public domain given to this NVIDIA server, through which you can use this server anytime and anywhere. Okay, so a login would be given to you. Okay. So basically, if first thing is, if you want to utilize this NVIDIA server for your AI and ML algorithms, there are two options. Okay, two things here. For the NMAMIT faculty or student, they need to drop a mail to me for the requesting the access to the NVIDIA server, and then you will be given with the username and the password. Okay, for the people or for the researchers who are outside NMAMIT, again they can drop me a mail, and you would be given an access to the NVIDIA server. Okay. For the students or the faculties who are inside the college, you can access the NVIDIA server using the IP address 172.16.2.15. Okay. Let me clear this once. So the local IP address, the internal IP address is the 172.16.2.15. Okay, through which you can access the NVIDIA server. And for the faculties or the researchers who want to access the NVIDIA server outside NMAMIT, they can go with gpu.nmamit.in-p. The port number is 202. Okay. So the students and faculties at NMAMIT, they can even use the NVIDIA server from outside NMAMIT using this public domain, that is gpu.nmamit.in. Okay, port number is 202. So as I am inside the college, I would be using this. And -x is not actually required. You can just go with the SSH, the username, okay, at 172.16.2.15. That is sufficient. Okay. So now, once you log in with this, you are inside the NVIDIA server. That is how you see Ashwini at Boston AI. Okay. One more thing I want to give a slight information is, if you are interested to learn or to say, suppose you require some of the platforms, then you can we have a NVIDIA. Okay. Okay. So this is one more website, ngc.nvidia.com, where you have different containers. Okay. So initially, if you are the first time user, you can just click on ngc.nvidia.com, and then you need to sign up. Okay, it is better if you sign up with your institution mail IDs. Okay, once you sign up, then you would be given with a authentication to log into this ngc.nvidia.com, and inside this ngc website, this is purely from the Nvidia itself, and there are lot many containers in this Nvidia page. Okay, so you could use any of these containers to execute your AI or ML algorithms. Okay, so you could have you can have TensorFlow, so you can have TensorFlow container, CUDA container, Cafe, TensorRT. So there are various set of containers which you can use in your AI or ML implementations. Okay, uh, see if I'll just tell you. See, these are the Docker images which are already available in the NVIDIA server currently now. Okay, so many of our faculties and the students are using, as I've said, they are using this NVIDIA server for their research purpose. So you can see that this is the image. Okay, this is the image which someone has pulled from nvcr.io NVIDIA TensorFlow, and this is the version, this is the tag. Okay, 20.08 tf1 p/3. Okay, so now this image can be used to execute your AI or ML algorithms. Okay, so we are providing you a platform where you can implement your AI and ML algorithms in a faster way. Okay, so now the question comes, how do you pull these containers? Okay, if I want TensorFlow, or if I want PyTorch, or if I want the CUDA, okay, how do I pull these images? Okay, as I've told you, there are various containers in this ngc.nvidia.com. Once you log into this ngc.nvidia.com page, there is a setup. Okay, you can see that there is a setup. So click on this setup. You will find two things here: install ngc CLI and generate API key. So you can just click on this get API key. You will be okay, this page would appear. So here, using this credentials, that is docker login nvcr.io. Let me. Okay. So once you log in with the, okay, so I'm currently in the server, so you can just give docker login nvcr.io. Okay, so here I had already logged in, so it is just authenticating with the existing credentials. If you're the first timer again, so you can just give docker login nvcr.io, and it will ask you a username and password. So the username is given, default username is the same one, $OAUTH token. Okay, and to generate the password, you can just click on generate API key. Okay, so generate API key will give you some junk values here. Okay, so you can just copy this username and password and then log in to your NVCR. So once you log into nvcr.io, you can easily pull the containers. So as I've told you, there are various containers in the NGC page. Okay. So there are various containers in the NGC page here. So I can just, let me see here, TensorFlow. Okay. So when I click on TensorFlow, it gives me a pull command, docker pull nvcr.io. So this particular command, you can just copy this command and paste it here, and then it starts. It's, of course, this is already there here, so this is not required. But then when it is the first time, you can obviously pull this particular container using this particular command. Similarly, you do have other pages like Docker Hub, okay, hub.docker.com, where you can sign up, and then again you can use various containers provided by the Docker Hub. Okay, so once you pull the container, okay, let me go here. Once you pull the container, you can easily run the container using, so you can run the container using this particular command. Let me give you a command here. Okay, so this is the Docker run command, which is used to run the Docker images. Okay, so to run the Docker images, you can just give Docker run and the various options. Okay, so I is for interactive. Okay, otherwise if you do not give I, you will just run the container and it will exit. You cannot actually enter or interact with the images or give the inputs. So that is why we give I here. And we also need a terminal. Okay, TTY terminal is required to execute your programs by giving the user inputs, and also the outputs should be shown. So that is where the terminal. So that is why you give -it. -v is for the volume. So this home/Ashwini is my local or the local host folders, okay, the desktop folders, and this test1 is the folder in the Nvidia server. Okay, of course you need not give this also. -v is not required. You can just give docker run -it, and you need a port number. Okay, you need a port number to run your images. So you can just give -p and some port number. I have given here 8001. You can even give 8002, 3, 4, whatever, colon the 888 port number and the images. So this is the image which I am trying to execute. Okay, run. Okay, so now when I execute this particular command, you can see that I have entered the Docker container. So now I am in this particular TensorFlow. Okay, so this is the TensorFlow, is the image which I'm executing in my container, which I'm running in my container. So now here I can just give Jupyter/lab. Okay, and this will enable, this will give me a URL. Copy this URL, copy link, and then go to your browser, paste that particular link, and change the host name and the port number. So here the port name is 16.2.15. I mean the host name, and the port name is 8001. So now this is where you have got the Jupyter Lab, and here you can see that you have notebook, then the console, and there are various other things. So you can whatever is relevant to your application, if you want to run it on the terminal, or you can have a notebook, so you can directly go to the Jupyter and then type your AI or ML programs. Okay, so this is, and now this particular AI and or the ML algorithms, whatever you have implemented, will be executing in the Nvidia server. It is not executing in your local machine. It is executing in the Nvidia server, which has 2 Tesla P100 GPU cards, by which you can say that even you have 10,000 images, your training could be done in a fraction of seconds. Okay, so that is where the Nvidia server is very helpful for us to implement more of AI and ML algorithms. Now as we have a separate AI and ML branch, we obviously see that there could be a lot many increase in the AI and ML projects. And as I've been said here, this particular meeting is actually, the audience are the first years, okay, who are joining the AI branches, and maybe some of the students in the CSIS branch. uh, uh, Not only CSIS, of course, AI and ML is interdisciplinary. Any of the branch students can use this NVIDIA server. Okay, so that is what I want to convey. I wanted to convey to the audience, saying about the giving an information about the infrastructure what we have to enable the AI and ML projects to execute more faster. So you need not rely on your laptop machines. You need not purchase a higher configuration laptops or desktops, whatever. You can utilize the NVIDIA server. Okay. um, of course, there are a lot many things to be learned in Docker again. Okay, you can obviously go to Google and just press Docker, and you will get lot many commands. Okay, I've just given you a Docker pull command and Docker run command, but that's not enough. Okay, but then I don't think I can take more time here to explain all the Docker commands. Maybe we should have a separate sessions for using the Docker commands there. um, yeah, so that's what I wanted to convey here. Thank you.
Thank you, ma'am, for an informative session on how to use NVIDIA server for the development of AI projects. Thank you so much.
Thank you.
We have come to the end of the webinar session. I express my gratitude to all the speakers of today for sharing their views with us. I also thank the participants for their participation in the series and making it a success. I would like to thank Dr. Jyoti Shetty for initiating and organizing this session as a part of AI Center of Excellence. Thank you, everyone. Actually, I forgot to ask you regarding any questions you had in the last session. I'm really sorry about it. I think before we wind up, any questions for the last session to Dr. Ashwini B?
Yeah, and of course, any of you, I can understand that some of you might not understand initially what is Docker and how to go with it. You can always drop a mail to me, okay, ashwinib@nitte.edu.in. And even if you want an access to the NVIDIA server, drop a mail to me. Okay, thank you.
Thank you, ma'am. I'm sure they would reach out to you if they need any help regarding it. Thank you, audience, then. 1 second. Okay, I think we can end the session. Thank you, everyone, for your wonderful support. Thank you.